Our objective in this lesson is to illustrate inverse variation. Let's have a quick review of our previous lesson. For numbers 1 to 3, is it a direct variation or not? Number 1, notice this operation here. This is not a direct variation. Number 2, this is a straight line that passes through the origin. So yes, this is a direct variation. Number 3, 20 divided by 10 is 2, 2 divided by 1 is 2, 12 divided by 6 is 2, but 10 divided by 20 is 1 half. So this is not a direct variation. Number 4, write the equation. The cost, C, of chicken varies directly with its weight, W. So C is equal to K times W. Number 5, let us determine the value of K. Negative 8 divided by 4 is negative 2. Negative 16 divided by 8 is negative 2. 12 divided by negative 6 is negative 2. And negative 6 divided by 3 is negative 2. So K is equal to negative 2. Today we are going to talk about inverse variation. It is a relationship between two variables, such that if one variable increases, the other variable decreases. For example, if you are given two quantities x and y, an increase in x causes a decrease in y, or vice versa. Inverse variation happens whenever the product of the values of corresponding pairs of variables, example x and y, produces a non-zero constant. In symbols, xy, this is the product, is equal to k, where k is the non-zero constant. It is the constant of variation or proportionality constant. Here are some statements of inverse variation. Y varies inversely to x, y varies inversely as x, and y is inversely proportional to x. So if we have y is equal to k over x, this is read as y varies inversely as x, or y is inversely proportional to x. So if we have m is equal to k over n, this is read as m varies inversely as n, or m is inversely proportional to n. If we have p is equal to k over q, this is read as p varies inversely as q, or p is inversely proportional to q. Now, how do we determine if an equation is inverse variation? Here are some things that you have to remember. There are only two variables, example x and y. The exponent of each variable in the equation is just 1. The variables are multiplied, and our k is not equal to 0, meaning the product of the variables is not equal to 0. Let's have an example. We only have two variables here, y and x, and the exponent of y and x here are both 1. Now, are the variables multiplied? Let's see. Let us move negative 2 over x on the other side. It will become positive. Let us do cross multiplication. So we have y times x is equal to 2. Now, the variables are multiplied. And our k here is not equal to 0. So yes, this equation is an inverse variation. Let's have another one. We only have two variables here, y and x, and both y and x have an exponent of 1. Now, are the variables multiplied? Let us move negative 3x on the other side. It will become positive. And 8x plus 3x is 11x. Now, the variables are not multiplied, but the variable x is multiplied to our k. So, this equation is not an inverse variation. Another one, we only have two variables, y and x. The exponents of each are both 1, and obviously our variables are multiplied, and our k is not equal to 0. So yes, this is an inverse variation. Another one, we have two variables, y and x. Each has an exponent of 1, but the variables are not multiplied. So this is not an inverse variation. Last one, we have only two variables, y and x, but the exponent of x here is 3, not 1. So this is not an inverse variation. Now, how do we determine if a table of values is inverse variation? Remember these three. Again, there are only two variables, let us say x and y. The product of the values of the corresponding variables should be constant, and the table does not have x equals 0 or y equals 0. Let's have an example. We only have two variables here, x and y. Now let us determine the product. Negative 8 times negative 3 is 24. 6 times 4 is 24. Negative 12 times negative 2 is 24. And 24 times 1 is 24. The product of each corresponding variables is constant. They are all equal to 24. And we do not have x equals 0 or y equals 0. So yes, this table is an inverse variation. Let's have another one. This is not an inverse variation. Why? Because we have three variables here, x, y, and z. Another one, we have 5 times 6 is 30. 3 times 10 is 30. 1 times 30 is 30. 2 times 16 is 32, not 30. So this table is not an inverse variation. Another one, we have two variables here. Let us determine the product. 4 times 8 is 32. 32 times 0 is 0. We have y is equal to 0. Hence, this table is not an inverse variation. Last one, we have only two variables. Now let us determine the product. Negative 6 times 6 is negative 36. 9 times negative 4 is negative 36. Negative 18 times 2 is negative 36. And 1 times negative 36 is negative 36. The product of each corresponding variables is constant. It is equal to negative 36. Therefore, this table is an inverse variation. Now, let us talk about graph of inverse variation. Let us recall the table that we had earlier. What I did is I graphed this in a Cartesian plane. Negative 8, negative 3 here corresponds to point A and it is here. 6, 4 corresponds to point B and it is here. Negative 12, negative 2 corresponds to point C and it is here. And 24, 1 corresponds to point D and it is here. What I did is I added some more ordered pairs, wherein the product of each ordered pair is also equal to 24. And here are some of the ordered pairs that I added. And when I connect the points, I form this graph. Now let us observe. The graph is a curve. It is neither a straight line nor a parabola. Another observation, notice that our graph approaches x is equal to 0. In this one, it also approaches x equals 0, meaning the graph has a vertical asymptote at x equals 0. Also, the graph approaches the line y equals 0. In here, it also approaches the line y equals 0. So the graph has a horizontal asymptote at y equals 0. Last one, as the absolute value of one variable increases, the absolute value of the other decreases. Notice here, 5, 10, 15, 20, it increases. And let's take a look at here. Let's get the absolute value. 20, 15, 10, 5. It decreases. Here are some more facts about graphs of inverse variation. The graph of it is called hyperbola. So in here, I have three sets of hyperbola. I have the blue, the violet, and the orange. The pair of these alternate curves are called branches. The location of the branches has something to do with the value of k. When k is positive, the branches lie in first and third quadrants. Like the blue graph and the violet graph, it lies on first and third quadrants, meaning the value of k in these graphs is positive. If the branches of the hyperbola lies on the second and fourth quadrants, the value of k is negative, like in this orange graph. It lies on the second and fourth quadrants, so the value of k here is negative. Another thing, the x and y axes serve as the asymptotes. I already explained this earlier. The graph approaches the y-axis and it also approaches the x-axis. Now for the domain, the graph will extend indefinitely to the left and to the right, but it will not pass through 0. So the domain is set of all real numbers except 0. Now, how about the range? The graph will also extend indefinitely going up and going down, but again, it will not pass through the origin. Therefore, the range of inverse variation is the set of all real numbers except 0. And as mentioned, the graph will not pass through 0, 0. This is because 0, 0 can never be a solution of an inverse variation equation. Now let us determine if the graph is inverse variation. Let's have the first one. This is an inverse variation. How about this? No, it passes through the x-axis. How about this one? This is a straight line, so no. This one? Also no, because it passes through the y-axis. How about this one? Yes, this is an inverse variation. Last one, this is not an inverse variation. It passes through the x-axis as well as the y-axis. Now, let us write equation of inverse variation. First one, the acceleration a of a car varies inversely to its mass m. So a is equal to k over m. A is inversely proportional to M. Another one, the base B of a triangle is inversely proportional to its height h. So B is equal to K over H. Next one, the cost C of renting a boat varies inversely to the number N of persons sharing the cost, assuming that they will all share the same amount. So C is equal to K over N. Next one, the time T required to finish a job varies inversely with the number N of people who work on the job, assuming again that they will do the same amount of work. So T is equal to K over N. Last one, the pressure denoted by P of a balloon is inversely proportional to its volume denoted by V. So P is equal to K over V. Now let us solve for the K of an inverse variation. Y is equal to 2 when X is equal to 7. Let us recall the equation of inverse variation. Now let us do cross multiplication. So K is equal to YX or XY. Let us substitute the value of X, which is 7, and the value of Y, which is 2. 7 times 2 is 14. This is the value of K. Another example. So again, the equation, let us do cross multiplication. Let us substitute the value of x and y in here. Let us multiply. So k is equal to 100. Next one, let us recall the equation. Cross multiply, substitute the value of x and y. Zero point 0.5 times zero point 0.6 is 0.3. That is our k. Last one. Again, the equation is y equals k over x. Cross multiply. Substitute 25 and 15 for x and y respectively. And 25 times 15 is 375. This is our k. Let's have another activity. Missing values. Given that y varies inversely with x and y is equal to 8 when x is equal to 3. Find x when y equals -4. The easiest way to answer this is to make use of a table. Now let us supply the values here. Y is equal to 8 when x is equal to 3. Find x, so this is unknown, when y is -4. Let us recall the formula for k, that is y times x. Let us substitute y and x here, that is 8 times 3, and this will give us 24. Now that we already know the value of our k, let us substitute this to the inverse variation formula. So y is -4 and k is 24. Cross multiply, this will become -4 times x is equal to 24. To solve for x, let us divide both sides by -4. This will cancel out, and 24 divided by -4 is -6. So -6 is the value of our x here. Let's have another one. Given that y is inversely proportional to x and y is equal to 28 when x is equal to 2. Find y when x equals -4. Let's have our table. Let us supply the values. Y is equal to 28 when x is equal to 2. Find y. So this time we are looking for y when x is equal to -4. Again, k is equal to y times x. Let us substitute the values of 28 and 2 here. That will give us 56. Now that we already know the value of k, let us substitute it to our formula. Our y is unknown. Our k is 56. Our x is -4. So 56 divided by -4 is -14. This is the value of our y when x is -4. Try this. The variable y is inversely proportional with x. The value of y is 5 when x is equal to 6. Letter A. Write an equation that relates y and x. Letter B. Find the value of x when y is 60. So to answer letter A, let us recall the inverse variation formula. Let us do cross multiplication. So k is equal to y times x. We already have the value of y, that is 5, and x is 6. So 5 times 6, and that will give us 30. Now that we already know the value of k, we can substitute it in our formula. So to answer letter A, y is equal to 30 over x. Letter B, find the value of x when y is 60. So all we have to do is to substitute 60 in our y here. Cross multiplication, 60 times x is equal to 30. Divide both sides by 60. This will cancel out. 30 divided by 60, and that is equal to 1/2. That is the value of x when y is 60. Suppose we are given a point. How do we write the equation? So let's have an example. Write an equation of inverse variation that passes through -2, 8. Step 1 is start with the function form of the inverse variation, and that is y is equal to k over x. Step 2, let us substitute the values of x and y. So our x is -2 here, and our y is equal to 8 here. Then let us solve for k. We can do that by cross multiplication. So k is equal to 8 times negative 2, and that is negative 16. And last step, substitute the value of k in the original formula. So we have y is equal to negative 16 over x. This time, let us have real-life application of inverse variation. Suppose that the volume denoted by V of a gas varies inversely as the pressure denoted by P on it. If the volume is 180 cubic centimeter under pressure of 15 kilogram per centimeter squared, what pressure has to be applied to have a volume of 90 cubic centimeter? To answer this, let us form the inverse variation equation. So V is equal to K over P, inversely proportional. Cross multiplication, K is equal to V times P. Our P is 15 when the volume is 180. So 15 times 180. And this will give us 2,700. Now that we already have the value of K, we can substitute it here. And we also have the volume, which is 90. So V is 90 and K is 2,700. We only have one variable left. Let us do cross multiplication. 90P is equal to 2,700. To solve for P, let us divide both sides by 90. 90 will cross out, so we have P is equal to 2,700 over 90. And this will give us 30. To answer the question, a pressure of 30 kilogram per centimeter squared must be applied to have a volume of 90 cubic centimeter. Let us do extra challenge. The distance d that the person on seesaw sits away from the fulcrum is inversely proportional to his weight w. Julio and Julia are trying to balance the seesaw. Julio, who weighs 40 kilograms, is sitting 2 meters away from the fulcrum. How far should Julia, who weighs 38 kilograms, be sitting to balance Julio? To easily answer this, again, I'm going to make use of a table. So I have here the variables d for distance and w for weight. So I have here Julio weighs 40 kilogram. So w is 40 and he is sitting 2 meters away from the fulcrum. So the distance is 2. How far should Julia, so the distance is unknown, if she is 38 kilograms? Since D is inversely proportional to W, we have D is equal to K over W. Cross multiplication, K is equal to D times W. We already have the value of D, that is 2, and W, which is 40. Let us multiply them. This will give us 80. So our K is equal to 80. Let us recall this formula and substitute 80 for K, while W is 38. So we have 80 divided by 38, and that is equal to 2.1. So if Julia weighs 38 kilograms, she must be 2.1 meters away from the fulcrum to balance the seesaw. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. For numbers 1 to 3, is it inverse variation or not? XY is multiplied and our K is not equal to 0. So yes, this is an inverse variation. Number 2, we have a graph here of a hyperbola. So yes, this is an inverse variation. Number 3, we have here 0 for x. So this is not an inverse variation. Number 4, let us write the equation. In kickboxing, the force F needed to break a board is inversely proportional with the length of the board. So F is equal to K over L. And last one, determine the value of K. Negative 3 times negative 6 is 18. 9 times 2 is 18. 36 times zero point 0.5 is 18. And 1 times 18 is 18. Therefore, our K is equal to 18. Gets? Don't forget to comment your scores below. Our next lesson is joint variation.